Okay, here we are on page 454, I think it is. Page 454. So we're talking about blood cholesterol for men 20 to 34. The average for the whole population is 188, and the standard deviation is 41. Now, letter A. What happens if we take a simple random sample of 100 men from the population? What is the sampling distribution? What that means is if we took many samples of 100 men from this big population and took the average, what would the distribution look like? Well, so this is for letter A, and the average of all those samples, right, what would the distribution look like? Well, it's going to be 188. Why? Because Ishmael would say that it's an unbiased estimator. But then how do we get the new standard deviation of all of those averages? Well, you take the average that you had for that standard deviation, let's see, 41, and divide it by the square root of your sample size. There you go. What just happened? Okay. That. Okay, there you go. Which is going to be 4.1. See, the old standard deviation was 41. The new standard deviation is 4.1. Much better information. Now, letter B talks about, well, what's the probability that we get a sample that's plus or minus 3 higher or lower than what the average is? So I did 2 different z-scores. This one over here shows a z-score where it was 3 higher, 3 points higher, I guess you would say, when they talk about blood pressure. And this one is 3 lower. So we're going to get these 2 different z-scores. So it's between 0.73 and negative 0.73. So again, I always draw this graph. Remember, 0 is in the middle. That's the exact average. So we're 0.73 standard deviations above and 0.73 standard deviations below. What is the probability that we get a sample in that range? And we're going to do normal CDF. But what I'll do is I think I'll just cheat, and I will just put the lower bound as negative 0.73 and the upper bound as 0.73 in the calculator, and I'll see what that is. And it tells me that, whoops, right there, that area in that graph is 0.534, 0.534. So there's a 53% chance that I would get a sample that is higher or lower 3 than our average. Okay, that's B. Now what if I think what they ask is, you take a bigger sample, so 1,000 instead of 100, which is going to do what? Well, it's going to change our standard deviation. So we're going to do the problem again, but with a different standard deviation. So this is our new standard deviation with a larger sample size of 1,000, which gives us a smaller standard deviation. That seems to make sense. Larger sample size, more accurate results. We're really narrowing in on that 188. So let's do the problem again. So we get 2.31 as our z-score. Now we're going to use those z-scores in our normal CDF. I'll just use negative 2.31 and positive 2.31 as our lower and upper bound, and see what's the probability that we would get a sample size in that range, plus or minus 3 points from 188. Notice that I rounded the standard deviation to 1.3. This was close enough to 1.3 because that's what they used in the book. Okay, so let's see what that is. So if you think about what that picture looks like, 2.3 standard deviations in this normal curve. So here's 0. We're way out here and way out here, right? So we have a very good chance of getting a sample that's at least in between those two ranges from 191 to 185, we have a 97.9% chance of getting a sample that's in between these two. Okay, that's what that's saying.